Hi, my name is Mike Miller. I'm the General Manager of the AI Devices team at Amazon Web Services. I've been with Amazon for 8 years, the first 4 of those at Lab 126, where I ran product management for the Fire TV line of devices. I've spent the last 4 years with Amazon Web Services, leading the teams that built devices like AWS Deep Lens, AWS Deep Racer, and AWS Deep Composer. Those products' goal is to put machine learning into the hands of developers of all skill levels in a fun and hands-on way. I wanted to thank Eagle Dream Technologies for having me today, and I'm excited to talk to you about how your company can get started on its machine learning journey. We live in a golden age of AI and machine learning, where so many things are possible that you hear many leaders and CEOs talk about machine learning is the future. Let me start by saying it's not the future, it's happening now. When we talk to business leaders, they don't need much convincing as to why they need to do machine learning. IDC predicts that 2020 AI spending will reach over $50 billion, which represents a 32% jump from 2019. It's clear that organizations understand the ML imperative, but they struggle to get started. The question that I get now is not why should I do ML, but rather how do I do ML and where should I apply it? With the abundance of compute power and data, and quite literally, machine learning is now making an impact across every industry, from finance to retail to fashion, real estate, and more. It's moving from the peripheral to impacting the core part of every business and industry. ML is helping large companies streamline their back office processes and improve customer experiences. For instance, Intuit has built forecasting capabilities that predict call center demand on a particular day or time to make sure customer service agents are adequately staffed. In healthcare, AI Doc uses AI and image recognition tools to augment radiologists' expertise, analyzing CT scans to flag acute abnormalities, prioritize life-threatening cases, and expedite patient care. Startups are being built on the backs of machine learning as well. Convoy, a Seattle-based logistics company, is building their entire company and value proposition off the use of machine learning. The company is disrupting the inefficient trucking model by using machine learning to automate it. Convoy uses machine learning to provide better matches for shippers and truckers, allowing them to move freight more efficiently and lowering costs for both parties using Convoy's matching system. And in the public sector, NASA is using unsupervised learning and anomaly detection to explore the extreme conditions associated with solar superstorms. But even with the increased adoption of machine learning and the hype associated with the technology, it's still in its infancy. We're just scratching the surface of the impact that ML can have across industries and geographies. Amazon itself is an example of a company that went through a multi-year machine learning journey in order to be the ML-driven company you see today. Amazon had been applying ML in areas such as personalization and supply chain for more than 20 years. ML is an integral part of Amazon. And in fact, we've improved that original personalization model significantly over time and moved it to other products, such as Amazon Prime. We use ML throughout our fulfillment process, including developing a forecast system that can predict the appropriate amount of demand for each product we sell worldwide in order to deliver on customer expectations for convenience, cost, and delivery speed. We've developed natural language processing technology to give consumers an entirely new way to interact with technology through Alexa. We've also developed groundbreaking technology with autonomous flight via Prime Air drones and using robotics in our fulfillment center to get packages to consumers faster. This was a big culture change for us, but it's something every organization can do. ML requires a cultural shift that's driven from the top. At its core, ML is experimentation that gets better over time, so organizations must also embrace failures and take a long-term view of what's possible. At Amazon, we took a unique approach to how we would get started incorporating machine learning. 10 years ago, the leadership team asked every business leader at Amazon, irrespective of whether they run a research team, a fulfillment center, or an HR organization, to answer the question, of how they plan to use machine learning in their business. "We don't plan to" was usually not an acceptable answer. This forced leadership, domain experts, and technical experts to work together to address the question. Today, there's not a single business function at Amazon that isn't made better through machine learning, but this didn't happen overnight. It took a cultural and technological shift. We speak with customers on a regular basis, both those that have readily adopted machine learning throughout their organization and those that are just getting started. Through these conversations and our own journey at Amazon, incorporating machine learning into all our processes, we've learned 3 key things that lead to successful adoption of machine learning. The first is data. Machine learning must have data, and while there is a lot of it being produced, companies often struggle with how to manage it. The second is organizational uncertainty about how to get started with machine learning and where to apply it to the business to have the most impact. And third is the skills gap. There aren't enough people today who can build ML models. Let's start with data. It's often cited as the #1 challenge in adopting ML. In our experience, we find that more than half of the time in building ML models is spent in data wrangling, data cleanup, and pre-processing. If you don't invest in getting your data strategy right, the machine learning scientists you hire that you expect to invent new algorithms will spend a large proportion of their time dealing with data cleanup and management, or worse, getting frustrated because they lack what they need to solve big problems. To get this right, you need to enable your IT teams to break data silos to collect the right data in a safe and compliant way. The real hurdle we see is the inability to simply assess the data that enterprises already have. Data-driven decisions necessitate access to all your data, areas, systems, applications, and data sources by those who need it when they want it. You may have data in the cloud, data on-prem, or data at the edge. We see our customers bringing together all data into a data lake and using a modern analytics platform that can handle diverse data types, wide-ranging use cases, and multiple analytics approaches on top of that organization-wide data lake. Further to that, you'll need to know what data actually matters as part of your machine learning problem. We'll talk about that more as we continue the journey. So there are 3 important questions to ask yourself when starting out of these projects. What data is available today? What data can be made easily available? And in 1 year, what data will we wish we had started collecting today? When addressing what data is available today, you'll need to overcome data hugging, where teams think that the data they have is their data. Now, while it can work to start an ML project in these data silos in short term, long-term success requires you to break down these silos for a more expansive view of the data landscape. Along the way, you also need to make sure you have the right access control and governance. To help identify the right problem to apply ML to, sometimes we use a simple technique that assesses them across 3 dimensions: data readiness, business impact, and ML applicability, which is the chance of success based on the state-of-the-art and team skills. So here, a problem that might have high business impact, but no data and very little ML applicability is going to lead to a frustrated data scientist. On the other hand, lots of data and ML applicability with no business impact is basically a prototype to build an experience, but isn't going to drive meaningful change in your organization. Once you have your data strategy in place, the next challenge is to figure out where you're going to start to extract intelligence out of that data. We often see companies paralyzed by uncertainty with where to start. The key is to balance speed with business value. You'll need to work quickly to maintain momentum, trying to achieve something in 6 to 12 months, while also making sure it's important to the business. There are 3 things you'll need to look at when making the decision on where to start. Look for places where you already have a lot of untapped data. Next, evaluate whether it actually needs machine learning or whether this is more of a one-off data science experience. And lastly, you'll look at whether it will benefit from machine learning, or are you fixing a problem that isn't actually broken. A project that has all 3 is a strong ML project, but even 2 out of 3 is also a great place to start. And if you have multiple project contenders, You can rank these easily on a chart with some rough estimation to see which one you might want to prioritize first. One mistake we see companies make here is getting excited about ML and hiring a data scientist or asking someone to go figure out how to make ML happen in the organization. They work in a silo and build really cool machine learning models, mostly as proof of concepts, but they rarely solve real business problems. To make meaningful machine learning transformations, you have to have a blend of technical experts and domain experts working back on the business problem. This also helps with the culture gap and acceptance in the organization when you have a solution in production. The partnership gives your organization a head start on overcoming organizational inertia. When both teams are coming together early, shared buy-in and adoption happens much faster. Finally is the skills gap. The growth of artificial intelligence could create 58 million net new jobs in the next few years, according to the World Economic Forum. Yet, according to the Tencent Research Institute, it's estimated that currently there are only 300,000 AI engineers worldwide, but millions are needed. As you can tell, there's a unique and immediate opportunity to upskill today's workforce with ML skills. For developers, this means an opportunity to advance your career. And for organizations, this means that you aren't going to be able to just hire all the data scientists you need. So you need to focus just as much energy, if not more, in training your current workforce. At Amazon, we took an approach to both hire new talent and develop our existing talent. We developed a machine learning university that we've used for over 6 years to train our engineers on ML. Last year, we made a lot of this content available for free to customers, and we've seen well over 100,000 developers start their ML journey with this content since. Having strong training programs can also help you attract and retain talent. Online MOOCs with ML instruction at every level are also available. We partner with Udacity, Coursera, and edX to bring real-world training to students. We've also brought additional programs to market to help developers get hands-on with machine learning, including AWS Deep Racer, Deep Lens, and Deep Composer. AWS Deep Racer provides developers with the opportunity to learn, upskill, and get hands-on with ML through a fully autonomous 1/18th scale race car driven by reinforcement learning, a 3D racing simulator, and a global racing league. We hold corporate events designed to provide developers with a fun way to get introduced to essential machine learning concepts. And customers like Accenture, Morningstar, and Liberty Mutual have taken advantage of these events to upskill and train their workforce. And if you participate in our virtual league for AWS Deep Racer, you can race to earn full scholarships to the Machine Learning Engineer Nano Degree program from Udacity. And now, while addressing the skills gap is important, machine learning will only truly scale when we as an industry make it even more simple to do. At AWS, our mission is to take our rich experience and expertise with machine learning from across Amazon and put it in the hands of all organizations, every developer, every data scientist, and researcher. Said another way, we focus on simplifying the process so that we can widen the adoption of machine learning. First, we're looking at the ways we can make it easier for developers to build, train, and deploy machine learning models. Building a machine learning model is a complex process, and many of the tools that developers take for granted when building traditional software, like debuggers, profilers, and collaboration tools, have not been available to machine learning developers. With Amazon SageMaker, we're working to give ML developers these tools so that the process of building machine learning models becomes less complex and more scalable. We're also enabling developers with no ML experience at all to add intelligence with our AI services for things like personalization, forecasting, and more through simple API callable interfaces. Taking this even further, we're building intelligence into applications that IT departments and the entire company will benefit from. For instance, Amazon Kendra is an intelligent search service powered by machine learning. Kendra reimagines enterprise search for your websites and applications so your employees and customers can easily find the content they're looking for, even when it's scattered across multiple locations and content repositories within your organization. Or take Amazon Code Guru, which is a developer tool powered by machine learning that provides intelligent recommendations for improving code quality and identifying an application's most expensive lines of code. Customers can integrate Amazon Code Guru into their existing software development workflow, where they can experience built-in code reviews to detect and optimize the expensive lines of code to reduce costs. So, there's a lot of work that goes into getting a proof of concept into production for machine learning. But the bigger job is scaling beyond your very first ML project. To do this, there are key areas to plan for in the long term. The first is automating data and refreshing the process and pipeline. Writing code is just one thing. Data collection and data cleansing gets very difficult at scale, which is why companies that do this well will develop a dedicated machine learning ops practice. As organizations mature, they should implement more and more continuous integration and continuous deployment tooling and processes. Their data, training, and deployment pipelines should be codified, just like their regular infrastructure and applications. Next is security. As you're expanding or growing, you'll need to focus on who has access to what data and how long do they safeguard that data. You'll also need to bridge the gap between IT governance and agility. Measurement is also key. You'll need to develop effective measurement of different models over time, looking at accuracy and precision. Lastly, machine learning is a team sport. It shouldn't just live in one small team or within one role. Some companies choose to create a center of excellence to refine machine learning processes and then scale those out to broader teams, while others keep a more distributed model. In either instance, it's critical to have all the parties who will be involved in machine learning working on the process together and then operationalizing the knowledge through both tooling like shareable notebooks and broad distribution such as internal events or blogs. We've seen several of our customers create internal AI and machine learning blogs to share learnings, and at Amazon, we do internal webinars and events to help people learn from each other. So, companies are empowered to be more proactive versus reactive. Processes go from being manual to automatic, so that humans are free to innovate and invent. Customer experiences go from being general to being deeply personal. And finally, technology overall gets easier to use, more intuitive, and accessible. I hope this helped you along your machine learning journey. Thank you very much for having me. Bye.